Hello and welcome. In this video we'll be modelling the clamps for the clip-ons for the handlebar assembly. As usual, there'll be the timestamps in the description so you can jump to whichever section you're most interested in, whether it's the 3D CAD or the 3D printing or the assembly and discussion. And if this kind of content interests you, then please consider subscribing. Okay, so I'm going to start modelling the clip-ons here. For reference, what I've done is I've taken some side views and top views of some handlebars. I've just sketched out roughly the length and the angles. The angle we'll get here relative to the midplane is around 68 degrees for sports bikes like the CBR, for example. And then the angle of the handlebar relative to the side plane is around 50 degrees to horizontal, but if we consider the rake, it's around 27 degrees. That's for, say, like the Yamaha R7 or R6. I'm using these sketches just for reference. As I start to insert the handlebar and the mounting for the handlebar, I'll be using those as a guide. Now I want to use a similar mounting clamp as this feature, just to keep some consistency in this assembly. And I'm going to flip the location of the clamp to the other side because I want to have the new clamp for the handlebar, the actual bar itself, on the far side relative to the rider. Okay, so the original top yoke is about 20 millimeters deep or thick, so we're going to go with that for this model as well. Now what we can actually do, since we have these two sketches, is we can combine them into one single sketch. All we need to do is create a sketch. We can use any plane for reference, and then we come into create, we project, intersection curve. So from this we can combine these two to get a three-dimensional curve, and this is where I think we're going to get the handlebar to join in. Maybe we'll pull that back just a little bit. I think that looks about right. Okay, since it's just a tube, the orientation around here isn't so important, so I'm not too worried about that. Now I'm going to go joint, select the datum point of the tube. I'm going to select that joint there. So now we can come in here to the tube. We can just do a simple sketch on this plane. We know we have a 22 millimeter tube, and that 22 mm tube has roughly an 18 mm diameter internal, so it's only around 2 mm thick. So we can put that in. Does it clash? It does clash a little bit, so we'll update that again in a moment, or we can just chop it off later on. From there we can just extend that the full 250 millimeters. When we extend it, we just make sure that we're not, we keep it as a new body and we're not accidentally merging it with another body. Okay, so yes, I don't really want it to come into this material, so I'm just going to move this initial geometry. Just going to move these sketches a little bit. Okay, so I've repositioned the tube. Now it's time to start working on the material that we're going to build the clamp around this tube. So it's going to come out from roughly here at an angle around this tube, and then provide a clamp feature as well. So recommended work farm, position your handlebar before you model your clamp, because if you try to take your reference geometry of it now, for example, you create that offset. Let's just double check. Yeah, you create that offset, and then ideally we want this to be, a DM feature so that it's not linked to anything. But since it's further down the tree, if we convert this to a DM feature, it's going to capture everything into that feature, which we don't want it to do. And if we pull it back down the model tree, it's going to lose the position reference that occurs when we use the joint origin. So it's an unfortunate situation I've come to here. See how much we can undo without breaking the whole model. Did anything else break? So we can convert that to DM feature now, and then we'll rebuild the sketch geometry. In order to use this reference geometry, I'm going to create construction geometry. I'm going to go with an axis through the cone or cylinder. I'm going to put an offset plane right here. So I don't need to do all of what I'm going to do here, but just to prepare some bits. So I'm just going to take the external surface here, and I'm going to extrude a portion of this to be, I guess, like a dummy of the tube. I'm not going to be using this as a part of this feature. It's going to be used to cut out where the tube is going to go in. It's also going to add as a base for the geometry that I build around it. Okay, so if you can imagine, this feature here is just going to cut out a hole here. This is going to be part of the boss that I now need to merge in with the clamp. To merge this in, I'm going to hide off that feature here. I'm going to extrude this out a bit further, but I'm also going to taper it. I'm just going to use a tangent plane roughly around here. I'm just going to create a boss-like feature from here. Now I want to extrude in two sides. Okay, this one we'll fix it later on, since we can do some more machine cut processes. So you see, you can model something as a really rough block, and then as soon as you start adding in those extra detail features, it really does help to clean it up. So don't be worried if it looks too blocky as you start. It is going to get better as you go. Okay, so for the fixing of the handlebar, I think I'm going to use a method that's more like a couple of screws coming in, and it's going to screw into the tube itself. So we can figure that all out later if we want to change to a clamp-like feature. Yep. Okay, so then I'm going to extrude this block in here. Join that extrusion. I'm going to come back. I'm still in. I'm going to give a taper on there, but I don't want the taper on all the surfaces, so I'm not going to add a taper there. I'm going to give that extrusion again. I say join. That should be okay. Now I'm going to add taper features. So you come into the draft. This is my pull direction. My face is going to be this one, and these two. Relative to that surface, how are they going to behave? They're going to extrude wider. Nice 35-degree taper, okay. Then from there, I want to put a couple of bolt holes in here. Now this feature now I want to combine with this geometry here. Well, not this geometry, but this geometry. Just make sure that this tube is hidden, so we don't have any confusion there. Yes, so let's combine. This is my base, this is my tool, and I want to remove the material. See, my target body is this, the component that I'm trying to model. The tool body is the one that's making the cut, and then we specify cut. We're not creating a new component, and we don't need to keep the tool, so it comes all the way through. Then we can just make two. You can use the whole feature, select both here, but then we need to specify again, we want 6 mil. And then it doesn't matter which profile we use because we're just going all the way through. So I just roughly copied the geometry profile, the shapes of the original clamp, and I'm just putting in the last bolt feature. When you're modeling, be careful that any round features and things that you add within an assembled component are not going to conflict with the mating component. For example, the rounds here would now cause problems with assembly. So we'd have to make those smaller. Okay, so here's my finished mock-up assembly for the handlebars. I'm going to try and print these off now and then fit them to the rig that I prepared. So if you come to a model that you've got your component in, you'll get this indicator that it's out of date and you'll have to update that component. I've just come in here, I've updated it to the latest version. So you see now it's taking some time to load, and then I'm going to have those handlebars in this assembly. And we'll see some of the things that you need to watch out for when you're dealing with handlebars. Okay, so the first thing to notice, I've changed around the assembly order. So originally I was going to have the clip-ons below, now they're going to be above. So I need to make some adjustments to the height of this assembled in the assembly. Second thing to address is we have a number of things that are going to be assembled on. Oh, I need to fix that. Let's go back. Okay, so some things to be mindful of when you change something in your assembly or when you're working with handlebars. For this example, I'd originally planned for the handlebars to be underneath the top yoke, so now that has changed. I may need to drop the yoke down a little bit or redesign this section a little bit, or just extend the forks up. The main things to be aware of, however, is the clashing. So we've got a number of things still left to go on here. We have the switch cubes, you have the grips, it's going to thicken this out a bit. And then when you rotate the handlebars, you usually have a certain amount of degrees, like left lock to right lock. We want to make sure that we don't have any risk of interfering with the tank, for example. We don't want the handlebars to hit the tank as you rotate round. We also don't want to be hitting the fairings with our hands, the handlebar or the levers. We'll also often have the front brake fluid positioned around here on the handlebars. So that also has to make sure that we're not going to be interfering with the fairing here. So looking at this design, if I don't drop this down a little bit, I'll have to make a modification to the bodywork, which is no problem. I'll probably be doing that anyway, but I will probably drop it down as well. So okay, so we have the final assembly. We have the top yoke on the stanchions. Then we have the left and right hand clamp pieces. Now I have oversized them a little bit too much, so we'll have to make sure we pinch those properly later on. Then of course we have the handlebars. Unfortunately the handlebars came out a little bit too tight fitting, more of a kind of press fit instead of having any clearance allowing us to clamp it down. So really once we push this in, it's not going to need any fixings to hold it in, to the point that it actually split this piece open a little bit. So I'm gonna have to pick up some tools tomorrow, I think, just so I can sand this down or file it down a little bit more. I've tried sanding it with some rough 60 grit paper, but PLA is quite hard, so it's taking some time. Maybe I'll just get a file so I can file it down a bit faster. Maybe something to work the inside here, and then we'll squeeze those on. I'm also then going to do some finishing. So for these parts, maybe we'll go for like a grayish metal, or maybe we'll just stick black. I'm not decided yet. So I didn't want to print one very long piece on my printer. I don't trust that it's going to be a good print as high as this. I'm not even sure if you can print as high as that. So I printed them in multiple pieces, and then I'll have to glue or plastic weld them together. That's the length of the handlebars inside. Well, with a portion of it in here, it's going to be about this long, which makes sense because we have our brake lever assembly. That's not the brake lever, that's the clutch lever. We have a brake lever assembly which is going to go on here. before the switch cubes. So we're gonna have the handle to here, switch cube in between here. So yeah, looking about the right length. And then we'll have some fun redesigning these parts as well. Okay, on to the tools to continue reworking these. So I picked up some metal files and also a plastic file. And I had this lying around. If you do plan on prototyping like this, then I would recommend using ABS or PETG instead of PLA. It's much easier to work on. Okay, so to try and control this position, I should have some equipment to hold it, but if you don't, I'm just going to do something like a normal welding. Just going to do like some small tacks. Usually, of course, you would hold it whilst doing this as well. The only purpose of this is to melt the plastic in these locations and try to bond the two pieces together. So it doesn't have to be a full bond, just enough to stick them together. So since we have some tools to tidy these up later, we don't have to be so careful to make it tidy around this part. If you're really limited on these tools, then I would suggest take a bit more care. So looking at this one, so this is just like tacks. It's already pretty steady. So I'm just going to now fill the remaining gaps that we can see throughout here with a bit of plastic in the printer. Just going to weld this into this gap, and then we'll tidy it up with the files after. When working with 3D printing, these are plastic fumes that we shouldn't be inhaling them. I don't currently have a copper mask, but open your windows, make sure you have ventilation, and try not to hover over directly too much, whatever you're working on. You can see there's a lot of fumes coming off of that. You don't really want to be breathing that in. Okay, so we very roughly put those together. I'm going to file them down now to put them up. Okay, so we finished welding the two parts together. I had one of them snap as I was testing it, put it back together, and it's not perfectly straight, so we've dropped the bike, we got a bent handlebar. But it's okay, it's good enough for now. Then we have the two clip-on kind of parts. They're going to be going on the top. So let's start assembling this now. So we have this one. I'm just going to push this in here. Okay, that's the first handlebar. And then the right hand one. This one also split a little bit because I didn't allow for any clearance or any tolerance in the diameter of this tube. So we've got two handlebars. Those are going to mount. I wanted the clamps to be directly opposite, so it looks something like this. Now I don't have anything like grips to go on here, but I do have the brake and clutch lever that I ordered just for fun the other week. So, well, I could put those on. They should probably just slide on because I don't think they're going to be pinched up very tight. And considering I've sanded them down, I've filed them down a bit, they're not going to pinch up tight now, so I need to add on a bit of extra material there, I think. Okay, so we have this assembly now, so I have to pinch these up, the clip-ons, so that I can start handling surrounding parts without them, flopping around. I'm going to get some grips. I'm not sure whether to print some fake grips or purchase some cheap ones. For the levers, I mean, for now I can always put these on, but since I've filed them down to get them to fit this part, it's very loose, so I'm not going to be able to clamp that up. And I want to remodel this part anyway, so I don't want to have the mirror part here. I'm going to adjust these, just this design, and see if I can't make a slightly better assembly around here and some more adjustability in these levers. Same goes for the clutch. So yeah, this is the current jig. We'll have a little look at the design of the top yoke, bottom yoke, and triple clamps. See some of those features which are usually overlooked by the normal rider. But if you're interested in the mechanical side, the assembly, disassembly, how it all goes together and how we control the maximum angles that things can rotate, etc., etc., we'll take a quick look at those now. First we have the ignition barrel mount. This part rotates and does protrude quite a bit, so we have to be careful with the headlight here. Then we have the location screw for the clip-on and the steering lock plate. Now these lock plates have to be reinforced. You've probably seen videos of thieves kicking the handlebars to break these locks. Then we have the steering stop, which defines the maximum steer angle. There'll also be a metal tab sticking out of the headstock. Now this steering lock plate is actually reinforced and welded all the way around except for one spot at the bottom, which is to allow water to drain if it gets in. That's to help prevent corrosion. For clearances, we can see the handlebar comes very close to the fairings at the front, and when we pull right back here you have no room for your hand really, so this is quite unlikely, but we still need to be careful to include this space. Here we can see that the fairing is actually shaped here because of the way that the cables protrude from the handlebar, and they've ensured clearance probably around 20mm for anything that comes nearby. And as always, thank you very much for sticking around to the end, and I'll see you on the next one.